Okay, so let's start off by reading about getting to know box plots. Okay, so we are going to use following numbers: the lower extreme, which is the lowest data value, the first quartile, the median, the third quartile, and the upper extreme. Okay, now all of these are given to you by your calculator. Given the following set of marks for a Pure Math 20 class, determine the lower extreme, upper extreme, median, first quartile, and third quartile. Okay, so there's a set of marks. So we're going to enter these into our calculator. Let's turn your calculator on. What I always do is go second plus number 4, which is clear all lists, and clear all the lists. Okay, so if you've ever entered any other stuff in there, then it'll be gone. We go to Stat, Edit. We're into list 1. We're going to enter these marks. You can go up and down or across, whatever way you like. I'm going to go down because it's easier for me. Although actually these are in order, aren't they?
Yes, they are.
All right, so never mind. We don't need that then. All right, so how many marks are there? What do we got? We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 5 times 7 is 35. That puts the middle. Well, okay, what's the lower extreme? 35. What's the upper extreme? 94. Which number is in the middle?
71.
71, because it's what number of the 35?
It's in the middle.
Oh,
It's actually in the
you're just
middle.
actually going for the fine. You're going to do it that way. Okay, where is the first quartile?
Somewhere between 71 and 32.
Yeah, somewhere in between. Yeah, 62.
Upper left.
And where is the third quartile?
80. Oh.
Okay, so you find these, and you could put them into your calculator as well. It'd just be a waste of time, I guess. The box and whisker plot shown below represents the data above. To construct a box and whisker plot, we do the following. You draw a scale that begins at a value less than the lower extreme and ends at a value greater than the upper extreme. In this case, because they're marks, 0 to 100 is a nice scale for that, right? Because we know that marks will lie within that range. Below this scale, you're going to mark 5 values: the lower extreme, the first quartile, the median, the third quartile, and the upper extreme. You're going to draw a box from the first to the third quartile, and within this box, draw a vertical line at the median, right? So we're saying 50% of the data is in this box, 25% is in each whisker, and that the median is represented by the line there, splitting the box. Draw a horizontal line from those, so those are the whiskers, right? Each section of the plot, the left whisker, the left section of the box, the right section of the right whisker, contain 25% of the data. Okay, so you got 25% here, 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 and here. In any box plot, what percent of the data are below the median? 50% are below the median. Below the first quartile, 25%. Above the first quartile, 75%. In the box. In each whisker. I might just write this down, I don't really hear anything. Below the third quartile, 75% is below. Okay, any questions on this little bit? The box plot shown below represents a set of marks for another class. Use the box plot below, or use the box plot above to complete the table below. So what is the can we dispense with the chatter, please? Thank you. What is the lower extreme? 30. What's the first quartile? 50. What's the median?
64. No. 65.
I'm going with
It's
65.
65 though.
Yeah, by how much? If you honestly think that's 1/5 of a unit, Grant, then I suggest you get your prescription checked. What's the third quartile?
85.
And what is the upper extreme? So we know it's not this class. Because nobody would score a 30, right?
Yeah. We were thinking
Yeah, I know.
That's what you think until we
you
get
know.
to our next class.
The following information is known for yet another class. Lower extreme, first quartile, etc. Draw a box plot that represents the data using the scale shown, right? So the idea is we're going to mark these 5, we're going to put dots down, right? At the lower extreme, at the first quartile, 1/5 of the way between 55 and 60, which is 20%, which is about there. At the median, at the third quartile, which again is 1/5 of the way from 75 to 80, and at the upper extreme, which will be 2/5 of the point. Okay, so you're plotting 5 points, right? You draw a box from the second to the fourth point. You put a line through the third point, and you draw whiskers to the extremes. Okay, so that's it. That's box plot, right? It's a very nice graphical way of showing the data, right? We could say, hey, I mean, this 25%, the upper quartile is concentrated, right? This middle part here is more spread out, right? The second quartile is very spread over a range of 15 marks. This goes over 6 marks. Okay, that 25%, and so on. Sometimes data sets include values that do not seem to fit with the rest of the data because they are too low or too high in comparison with the other data values. These values are called outliers. The data for another set of class marks is shown below. Determine the lower extreme, the upper extreme, the median, the first quartile, third quartile, etc., etc., etc. Okay, so, you know, same deal. We got the same kind of box, right? So we got this, we got this, we got this. We've got 80, and what do we got? 62 as well. One mark. The 25 seems to stand out. Not necessarily in a good way. If you had a mark of 25, you'd stand out, but not in a good way. When compared to the others. To determine whether we would call 25 an outlier, we use the following information, right? So we have to decide, is this like it looks way out, right? Because it's like so far below the next lowest mark. You know, whereas the 94 is, 4 marks above the next lowest mark, right? But that 25 to 52, that's pretty big. So does it stand out? So we need to look at the interquartile range, the IQR, which is the difference between the upper quartile and the lower quartile. So what is the interquartile range? 80 minus 62, right? Which is 18. Okay, that's how it, so the answer is 18. This is how we get it, right? We take the third quartile and subtract the first quartile. If a data value is less than the lower quartile minus 1.5 times the interquartile range, or greater than the upper quartile plus 1.5 times the interquartile range, then the value is an outlier. So looking at the data above, 1.5 times the interquartile range is 27, right? So it's 1.5 times 18, which is 27. If you take the lower quartile and subtract 27 from it, what do you get? So it's going to be 62 minus 27, which is 35. If you take the upper quartile, which is 80, and add 27 to it, you get 107, which definitely nobody's scoring. So is 25 an outlier?
Yes.
Yes. Are there any other outliers? No. Okay. So, well, it's just yes period, no period, right? Okay, is 25 an outlier? Yes, because 25 is less than 35, right? And you need to know this, okay? So it's maybe something to keep in mind. You need to know how to determine an outlier, right? So procedure is you find the interquartile range, you multiply that by 1.5, you take that away from the first quartile, you add that amount to the third quartile, and you then look and see, do I have any values lower than 35 or greater than 107? All right, next up. Next I just keep scrolling because I'm in a Word document. Box plot. Actually, I'm just going to save this one. The box plot indicating the outlier is shown below. Note that the outlier is indicated with an asterisk and that the left-sided whisker is extended only to the smallest value that is not an outlier. Okay, so our next smallest value is 52. That's what we're going to put in here, and we're going to indicate the outlier. Okay, using the TI-83 or 84 or family thereof to graph a box plot. Choose Stat, Edit, enter the data in L1. Choose Second Stat Plot On. Choose the box plot, which looks like a box plot. XList is L1 and your frequency is 1 because we're not entering a table of data, we're just entering the data. Screen should look like this. Very important that you choose an appropriate window. Zoom Stat will do it for you if you don't want to manipulate the window. However, if you do, then the X-min and max are dictated by the lowest and highest data values. The Y-min and max are not relevant here. We don't have any real Y values, right? The box plot will always appear on the top of the screen. If you're graphing multiple box plots, they'll appear one below the other. You can plot up to 4 at one time using all 4 lists in the stat mode and all 4 stat plots. Okay, do we need to do one? No, I didn't think so. Okay. What? Do we need to do one?
Yes. Not yes, wait, I got to sit down.
Then go zoom stat. I don't think it will graph for you an outlier with an asterisk. Okay, so I think you'll have to know that on your own, right? I think it would just graph for you the actual data itself.
Oh, it still doesn't work.
Invalid dim just means you're doing something wrong. What's your frequency? Is it 1 or is it L2? No, that's your X list. What's your frequency? Okay, I'm not going to record this. Nobody.